Fractured analytics in DIPS discrete image processing software for geological applications, particularly in tectonic reviews and rock mechanics, involves several steps to analyze and interpret fracture systems from geological data. DIPS is primarily used for analyzing the structural geology of rock masses and can help in understanding fracture sets, orientations, and related stress fields. Steps for conducting fractured analytics in DIPS software. 1. Data preparation. Collect fracture data. Gather data from field observations, borehole logs, and photogrammetry methods. Ensure that you record the orientation, strike and dip length, and spacing of fractures. Data format. DIPS typically accepts data in specific formats like CSV. You'll need to convert your data into a format compatible with DIPS. 2. Input data into DIPS. Open DIPS software. Launch the DIPS application. Create a new project. Set up a new project and define its parameters. Import data. Use the import function to load your fracture data into the software. This will generally involve a straightforward upload process where you select the file containing your geological data. 3. Fracture analysis. Orientation analysis. Use the software to plot the orientation of fractures on stereonets. DIPS provides tools to visualize the orientation data in 2D and 3D, making it easier to identify patterns and clusters. Create ROS diagrams. Generate ROS diagrams from your fracture orientation data to assess the frequency and distribution of fractures based on their orientations. This can help identify dominant fracture sets. Fracture spacing and length analysis. Analyze the spacing and lengths of your fractures to assess connectivity and the potential impact on fluid flow or mechanical properties. 4. Statistical analysis. Utilize the statistical tools available in DIPS to perform quantitative analysis such as mean orientation, standard deviation, and other statistical measures. This can help in characterizing the geological features. 5. Modeling. 3D fracture modeling. If applicable, utilize DIPS's capabilities to create 3D models of the fractured rock mass. This is particularly useful for visualizing complex geological settings and understanding spatial relationships between different fracture sets. Integrate other data. If you have geophysical or geological mapping data, consider integrating these into your DIPS analysis for richer insights. 6. Interpretation. Analyze the results of your quantitative and qualitative assessments to draw conclusions about the fracture systems, their origins, and their implications for geological processes such as stability, resource extraction, or groundwater movement. 7. Reporting. Generate reports. Utilize DIPS's reporting features to create comprehensive reports summarizing your findings, analyses, and recommendations based on the fractured analytics conducted. 8. Validation and further exploration. Validate your findings with field check or secondary data sources when possible. Further explore additional datasets or conduct sensitivity analyses as needed. Best practices. Maintain rigorous documentation of data collection methods and analysis procedures. Regularly update and maintain data integrity within the DIPS software to ensure accurate analyses. Consider collaborating with other geologists or data specialists to enhance the accuracy of interpretations and findings. By following these steps, you can effectively conduct fractured analytics in DIPS software to further understand the geological framework of your area of interest.